All right, folks, what I want to do real quick, I'm going to go through, well, not quick, it'll take a little while, but I mean, I'm going to go through the questions pretty quick. This is a review. I'm going to go over the packet for review number 1 for the second test. Okay, so question number 1 says to factor negative 3x to the 7th minus 5x to the 4th plus 4x squared. Now, there is no number that goes into 3, 5, and 4, so we're not going to take a number out. However, we do have x to the second power. We have an x in every term, and we've got the smallest one is x to the second. Also, the lead coefficient is negative, so we're going to take a negative out. So we're taking out a negative, and then x to the second power. Then, negative 3 divided by negative 1 is just 3. Then x to the 7th divided by x to the second is x to the 5th. Negative 5 divided by negative is plus 5. X to the 4th divided by x squared is x squared. 4 divided by negative 1 is negative 4. And then the x squares cancel. And this is the answer to question number 1. It's just a real simple greatest common factor problem. We are not going to factor this any further. Let's try question number 2. All right, question number 2 says factor 2x to the third power minus 10x squared plus 3x minus 15. We got a third power polynomial. If we're going to factor, we might be able to do factoring by grouping. So I'm going to group these two, then I'm going to group these two. Here I'm going to factor out, I can take an x squared out, and 2 goes into 2 and 10. So I'm going to factor out 2x squared, 2x squared. 2x squared, or 2x to the third divided by 2x squared is just x. Negative 10 divided by 2 is negative 5, and x squared, those cancel, so I have an x minus 5. Here I can factor out a 3, a positive 3, so I'll put plus 3. 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. Got an x minus 5 and an x minus 5. That makes this 2x squared plus 3 as my first factor. Second factor is x minus 5. That's my answer. Moving on to question number 3. All right. Question number 3. We've got factor x squared minus 5x minus 36. Okay, it's a trinomial. It has 1 as the lead coefficient. It's an x squared, then x, then x the first, then constant. I might be able to do product sum factoring on this. Are there two numbers that multiply to negative 36 but add up to negative 5? Negative 9 and positive 4. So it's going to be x minus 9 and x plus 4, and I'm done. All right, that's question number 3. Question number 4. We're going to factor x squared minus 81. This is a difference of squares. We have a square here, we got a square here, so we know that a difference of square factors into, we're going to put an x here and an x here. Square root of 81 is 9. Put a 9 here, put a 9 here. Put a plus in one and a minus in the other. X plus 9, x minus 9. It's a special case of difference of squares. That's number 4. Question number 5. Let's see, we've got x squared minus 14x plus 49. Now notice, the middle term is even, it's a 14, and the last term here, that's a perfect square, right? Okay, so when we have a perfect square here and an even number, we want to know, is this the perfect square of half of this? Well, half of 14 is 7. Well, technically, half of negative 14 is negative 7. And negative 7 times negative 7 is positive 49. So this is a squared binomial, okay? So a squared binomial, we know it's going to end up as x minus 7 squared. It's x minus 7 times x minus 7. All right? Last one in the section on factoring, question 6 says 5x squared plus 27x minus 18. Now this one you may have to go back, if you don't understand what I'm about to do, you may have to go back to the video in week 6, day 1, on product sum grouping and do those examples again. But here's what I'm doing. I'm going to multiply. See, I can't do factoring by grouping from the beginning because I don't have 4 terms. So I'm going to multiply the first number times the last number. 5 times negative 18 is negative 90. So I got negative 90, and I need two numbers that multiply to negative 90 but add up to 27. And so since this is a negative number, it's got to be a positive number and a negative number. So I'm thinking 30 and negative 3. 30 times negative 3 is negative 90, and 30 plus negative 3 is 27. So those are my numbers. So I'm going to break this out. I'm going to leave this as 5x squared. I'm going to leave this as negative 18. And in the middle, instead of plus 27x, I'm going to put minus 3. Well, let's do it. Let's do this. I'm going to do it as plus 30x. And it doesn't matter what order you put it in, but you got to give each one of these an x. You got to put an x on here and an x on here and put them in the middle. Now we can group. I'm going to put parentheses around this. Also here, I'm going to make this a plus and then put a minus on the 3 and put it inside the parentheses. Remember, I've told you before, you should have a plus here when you're doing factoring by grouping. So here, is there a number that goes into 5 and 30? Yep, 5 goes into 5 and 30. I've got an x squared and an x, so I can take an x out. 5x squared divided by 5x, 5 divided by 5 is 1. X squared divided by x is just x. 30 divided by 5 is positive 6, and the x's cancel. So I got x plus 6. Over here, is there a number that goes into negative 3 and negative 18? Sure, negative 3 goes into both of them, so I'm going to put a minus 3 here. Then negative 3 divided by negative 3 is positive 1, so all I have left is x. Negative 18 divided by negative 3 is positive 6, and sure enough, as long as I get the same factor here and here, I know I did it right. So one of my factors is 5x minus 3. My other factor is x plus 6. And that's my final answer. I'm factored, done with question number 6. All right, let's go on to question number 7 now. Question number 7 says solve, and it's a quadratic. It says x squared minus 11x plus 20 is equal to x minus 15. When I solve a quadratic, I want to move everything to one side and then set it equal to 0. So I'm going to subtract x here, add 15 here, add 15 here. That's going to cancel this side, leaving me with 0. Bring down the x squared. Negative 11x minus x is negative 12x. 20 plus 15 is 35. This can be factored. Two numbers that multiply to positive 35 but add up to negative 12 are negative 7 and negative 5. So I've got x minus 7 times x minus 5, and I'm going to set that equal to 0. So now, I set each one of these. If I have two factors multiplied that are equal to 0, then I set each one of them equal to 0 separately by themselves and solve. Add 7, and I get x equals 7. Add 5, and I get x equals 5. These are my solutions. And I'm done. Moving on to question number 8. Okay, so now question number 8 says 2x squared minus 10x. 2x squared minus 10x. This is question number 8. Plus 7 is equal to 1 minus x. Again, it's a quadratic, so I want to set one of the sides equal to 0. So I'm going to move this stuff over to here. Subtract 1, subtract 1. Add x, add x. This side cancels and becomes 0. Bring down the 2x squared. Negative 10x plus x is negative 9x. 7 minus 1 is 6. Now here I could try maybe product sum grouping. 2 times 6 is 12. Are there two numbers that multiply to 12 but add up to negative 9? Well, in order for that to happen, it would have to be two negative numbers. Well, I've got negative 6 and negative 2. They multiply to 12, but they add up to negative 8. How about negative 4 and negative 3? Well, they add up to negative 7. How about negative 12 and negative 1? Well, they add up to negative 13. There are no two numbers that multiply, well, no two whole numbers that multiply to 12 but add up to negative 9. So you know what I'm going to do instead? I'm going to do the quadratic formula. Remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is b, this is c, and this is a. So negative b is negative 9. So negative 9 plus or minus the square root of b, negative 9 squared, minus 4 times a, which is 2, times c, which is 6, all over 2 times a, and a is 2. So now here inside the discriminant, negative 9 squared, that's 81. Minus 4 times 2, that's 8. 8 times 6, that's 48. So minus 48. Negative 9 is positive 9 plus or minus. Remember, this is x equals. I should clarify, this is x equals. So our solution x is equal to this. Now, 2 times 2 is 4. 81 minus 48, that's 33. So our final answer is going to be x is equal to, now I got to do two answers, 9 plus and 9 minus. So two answers, 9 plus the square root of 33 over 4, and 9 minus the square root of 33 over 4. And we're done. Okay, that's question number 8. Let's try question number 9. All right, question number 9 says 2x squared minus 5x plus 1 is equal to x squared minus 5x plus 12. All right, well, we'll add 5x to both sides, add 5x. We're canceling this side. Subtracting x squared, subtract x squared, subtract 12, subtract 12. Here we're going to cancel, cancel, and cancel, leaving 0. Here, 2x squared minus x squared is just x squared. Negative 5x plus 5x, well, that cancels also. So we don't have an x term. 1 minus 12 is negative 11. So we have x squared minus 11. Now, when we have an x squared and we don't have an x term, we can extract square roots. In order to extract square roots, we're going to put the constant back on the other side. So we're going to add 11. We get x squared is equal to 11. Now this is easy. We can take the square root of x squared and take the square root of 11. The square root of x squared is x. The square root of 11, we have the positive version and we have the negative version. So it's going to be plus or minus the square root of 11. So you can write it like this, or you can say x is equal to the square root of 11 and x is equal to negative the square root of 11. But again, there are two answers. Okay? There aren't always two answers, but there are usually two answers. The only time there's not two answers is when it can be factored, well, for the most part, when it can be factored, when it can be factored and it becomes a binomial squared. Then there's only one solution. All right, question number 10. Now, also, the one we just did, number 9, that one, you could actually do that with the quadratic formula. You can actually do you can do 7, 8, 9, and 10, all 4 of them with the quadratic formula. If you prefer the quadratic formula, then you can do all of them. I'm just showing you the way that I taught you how to solve them. All right, question number 10 is x squared minus 10x plus 30 is equal to 8. All right, well, I'm going to subtract 8 from both sides. Cancel. And I get x squared minus 10x. 30 minus 8 is 22 equals 0. Now here, this is not factorable, so I could do the quadratic formula. But because the lead coefficient is 1 and the middle term is even, I can actually turn this into a squared or a binomial squared. See, half of negative 10 is negative 5. And negative 5 times negative 5 is positive 25. So if this was a 25, I would be able to factor it. So what I'm going to do is I'm going to make it a 25 by adding 3. And if I add 3 here, I have to add 3 here. And now this becomes x squared minus 10x plus 25 equals 3. Now I can factor this as a binomial squared, and it becomes x minus 5 squared equals 3. Now that we have a squared term equal to a constant, we can now extract square roots. We can take the square root of this side and the square root of this side. That'll cancel the square and leave us with x minus 5 only. And then over here, we will have plus or minus the square root of 3. So there's two answers here, positive square root of 3 and negative square root of 3. Lastly, we're going to add 5 to both sides to cancel or to isolate the x. And we get x equals 5 plus or minus the square root of 3. You can leave it like this, or you can write two separate answers. X is equal to 5 plus the square root of 3, and then 5 minus the square root of 3. And there's our two solutions. That's question 10. Let's go ahead and try. Let's move on to question number 11. Question 11 gives us a quadratic and asks a quadratic function. We have 11. We have f of x is equal to 3x squared minus 12x minus 15. Okay, so now it says identify the axis of symmetry, and then it says identify the vertex. Then it says identify the y-intercept, then identify the x-intercepts. Okay. Well, I know that the y-intercept, this is the easy one. The y-intercept, all I have to do is plug in 0 for x. So if I put a 0 here, 0. Put a 0 here, 0. So here we are, negative 15, just like we learned in the polynomials. The last number right there, that's the y-intercept. The y-intercept is 0 and negative 15. So we're good there. Let's identify now the axis of symmetry. The axis of symmetry, remember, the axis of symmetry is that x equals negative b over 2a. So b in this case is negative 12. So it's going to be negative 12 over 2 times a is 3 in this case. So negative 12 is 12. 2 times 3 is 6. So the axis of symmetry is at x equal 12 divided by 6 is 2. The axis of symmetry is at x equals 2. Now to find the vertex, we just plug the axis of symmetry. The x-coordinate is 2, and then we just plug that into the function. So 3 times 2 squared minus 12 times 2 minus 15. Well, 2 squared, that's 4. Times 3, that's 12. So we have 12 minus, 12 times 2 is 24. And then minus 15. So minus 15. 12 minus 24, that's negative 12. Negative 12 minus 15, that's negative 27. So the vertex is at 2 and negative 27. All right. Last thing we have to identify is the x-intercepts. Okay. Now look at this function right here. And if you look at it, you'll see that it can be factored. First of all, we can factor a 3 out of all the terms. So if we divide out a 3, what we get is 3 times 3 divided by 3 is 1, so we just have x squared. Negative 12 divided by 3 is negative 4 with an x, and negative 15 divided by 3 is negative 5. This can be factored. Two numbers that multiply to negative 5 but add up to negative 4 are negative 5 and positive 1. So negative 5 and positive 1. If I put an x in front of each one, put parentheses around them, then put a 3 in front of them, this is now my function. And in order to find the x-intercepts, I set that equal to 0, just like I am solving a polynomial equation, just like I solved in questions 7, 8, 9, and 10. That's what I'm doing for the x-intercepts. So I'm going to set this 3 times x minus 5 times x plus 1. I'm going to set that equal to 0. And now, I don't need the 3. 3 can never equal 0. So I'm not going to set that equal to 0. But my other two factors, x minus 5, I have to set that equal to 0. And then x plus 1, I have to set that equal to 0. Here I'm going to add 5 to both sides, and I get x equals 5. Here I'm going to subtract 1 from both sides, and I get x equals negative 1. And so these are my roots, right? These are my roots. We've been learning about that. So one of my x-intercepts is 5, 0. The other one is -1, 0. And there's the answers to question number 11. All right, let's move on to question number 12. 12, we are going to graph a quadratic function. Only you weren't given the quadratic function. You were just told what this is question number 12. You were just told that the axis of symmetry is at x equals -2, and you were told that the vertex is at -2 and 5. You were told that the y-intercept is 0, 4, and you were told that the x-intercepts are -6, 0, and 2, 0. All right, well, this is actually, by the way, this is exactly like plotting a polynomial, only this time you're given a very precise coordinate plane, so you want to actually use the grid. So now, the axis of symmetry is at -2, so I don't have a grid here. I'm sorry, I don't have it drawn up on my board right now. So I'm going to go to 1, 2, and I'm going to draw a dashed line for the axis of symmetry, and I'm going to put x equals 2. Well, you don't have to draw it because you have it right on the coordinate plane at x equals 2, right? The vertex is at -2 and 5. Oh, excuse me, I put it in the wrong place. Why didn't you tell me? I know, it's a video. That's why you couldn't tell me, right? I had to discover it. Sorry, the axis of symmetry is at -2. That's -1, -2. That's over here. My apologies. Didn't mean to mess up your brain there, but I did fix it. All right, so the vertex is at -2 and +5. 1, 2, 1. Let's go 1, 2, 3, 4, 5. So we're going to put a dot there. That's the vertex. Okay? Then the y-intercept is at 0 and 4. That's 1, 2, 3, 4. That's right here. All right. By the way, since we're about to graph it, remember, we're 2 over here. We got to go 2 over this way. So we got to go over to -4 and up to 4 and put the matching. Remember, this is a symmetry. This is a mirror. So we got to put matching points on both sides. Lastly, the x-intercepts. One of them is at 2, 0. That's 1, 2, 0. The other one is at -3, -4, -5, -6. And now, lastly, you've plotted all the points, and now all you got to do is draw a graph. It doesn't have to be pretty. Just do the best you can. It's got to be a parabola through all the points, and there is your parabola. Okay? All right, that's question 12. Now, let's do question, let's see, question 13. Oh, we're starting to get into a couple easy ones here. Question 13 says, divide using synthetic division. And we got, I don't want to write this whole thing. You have it on the piece of paper. You can see it. X to the fourth minus 5x to the third plus 10x squared, et cetera, divided by x minus 3. So I'm going to, since it's x minus 3, I'm going to put positive 3 in the half box. X to the fourth has a coefficient of 1, then -5, then 10, then -20, then 26. Draw a line, put a 0 here. 1 times 3 is 3, minus 5 is -2, times 3 is -6, plus 10 is 4. I'm going to make sure, I'm going fast, so I want to make sure I don't make a mistake, especially because you're trying to learn from this. 4 times 3 is 12, minus 20 is -8. -8 times 3 is -24. 26 minus 24 is 2, so we have a remainder of 2. Now we have to interpret this. The original numerator, the divisor, was to the fourth power. So now this is going to be to the third power. It goes down by 1 power, right? So the answer is going to be x to the third power, 1x to the third power, but we don't put the 1 there, minus 2x squared plus 4x minus 8, and then we have a positive remainder, positive 2. So remember, we have to put plus 2 over the divisor with is, oh sorry, earlier I said divisor, I meant dividend. The divisor is x minus 3. This is the final answer to question number 13. Let's do question number 14 right below it here. So we're dividing by x plus 2. That means we're putting -2 in the half box. Then we have, now be careful here. We have 7x to the fourth, so a 7, but there are no x to the thirds, so I have to put in a 0 as a placeholder. Then I have minus 31x squared, so I'm going to put a minus 31 here. Then there are no x to the first powers, so I'm going to put in a placeholder 0. And then plus 12 at the end, so I'll put a 12 here. So please do not forget your placeholders, your 0 placeholders. So now I'll put a 0 here. 7 plus 0 is 7, times negative 2 is negative 14, plus 0 is negative 14. Negative 14 times negative 2 is positive 28. Minus 31 is negative 3. Negative 3 times negative 2 is positive 6. 6 plus 0 is 6, times negative 2 is negative 12. Plus 12 is 0. We have a remainder of 0 here. The original problem started as 7x to the fourth, so this is going to become x to the third. So this is now 7x to the third minus 14, x squared, minus 3x plus 6. No remainder. That means that this is our final answer. That is our quotient. Okay? Let's do question number 15 now. All right, let's see here. Make sure you get a good look at this. Pause it if you have to look at it again. All right. Okay, question number 15. Put up here. We're dividing x to the fourth, x to the third, x to the second. Oh, we don't need any placeholder zeros on this one. We've got x to the fourth, x to the third, x to the second, x to the first, and then a constant. So no placeholder. So we're dividing by x minus 5, so we put a 5.5, positive 5.5 box. Then we have a 2, a negative 10. Then we've got a 3 and a negative 17, and then a positive 6. Draw a line, put a 0 here. 2 plus 0 is 2, times 5 is 10, minus 10 is 0. 0 times 5 is 0. 0 plus 3 is 3. 3 times 5 is 15. 15 minus 17 is negative 2. Negative 2 times 5 is negative 10. Plus 6 is negative 4, so we have a remainder. So now, we started out as an x to the fourth, so now it's going to be 2x to the third. But look at our x to the second power. We have a 0. That means we're going to skip over x to the second. We're not going to write any x to the second term. We're going to jump straight to this positive 3, and this is the x to the second. This is the x to the first. So we're just going to put an x there, minus 2. Then we have a minus 4 as a remainder. So we're going to put minus 4 over the divisor, which is x minus 5. And this is the answer to question number 15. Can you maybe just remember, put a box around that. You want to draw my eyes to the answer. So you should always, your final answer, underline it or box it or something like that. Okay. All right, question number 16. So we've got here. 16, use the rational root theorem to make a list of all possible rational roots of f of x equals this thing. All right, we need our p's and q's. Remember, it's the last number, which is 8, over the first number, which is q. So in this case, the last number is 8, the first number is 9. So here, the factors of 8 are 1, 2, 4, and 8. The factors of 9 are 1, 3, and 9. So we're going to make a comprehensive list, positives and negatives. It's okay to put plus or minus. I'm okay with that. So first we're going to do 1 over 1, 2 over 1, 4 over 1, and 8 over 1. But when it's over 1, it's just a whole number. So we'll do 1, 2, 4, and 8. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now we're going to do these numbers over 3. So plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3, and then plus or minus 8 over 3. Now we're going to do all these numbers over 9, and then we're done. Plus or minus 1 over 9, plus or minus 2 over 9, plus or minus 4 over 9, and plus or minus 8 over 9. And that's it. We're done with question number 16. Moving on to question 17. Right. Question 17 says, use the remainder theorem to calculate the following output values of f of x. So in this case, f of x is equal to x to the third power. plus 4x squared minus 13x minus 20. Now, I gave you plenty of room down here to do synthetic division. One synthetic division under each one. It says, show your use of synthetic division for each output value. I have to see your synthetic division right here on the paper. You only have to do one per question. So it says, what is f of 3? And then it says, what is f of negative 2? So for 3, we're just going to put 3 in the half box. We've got a 1, a 4, a negative 13, and a negative 20. We're going to do synthetic division. 1 plus 0 is 1, times 3 is 3, plus 4 is 7, times 3 is 21, minus 13 is 8. 8 times 3 is 24, minus 20 is 4. And the remainder theorem says that the remainder from synthetic division is the answer you would get if you were to plug this number into the function itself. So the output value when you plug in a 3 up here is 4. And if you want to check it, you can use a calculator and plug it in, and you'll get 27 plus 36 minus 39 minus 20, and it'll equal 4. Now we're going to do negative 2. So we put negative 2 in the half box. We bring down a 1, a 4, a negative 13, and a negative 20. Right? And then we'll put a 0 here. 1 plus 0 is 1, times negative 2 is negative 2, plus 4 is 2. 2 times negative 2 is negative 4. Minus 13 is negative 17. Negative 17 times negative 2 is positive 34. And 34 minus 20 is 14. So the final answer here is 14. So we're done with 17. All right, let's flip it over. Now, on the next page I give you, because I stapled them wrong, is 21 and 22. But we're going to come back to those. Let's go to question number 18, which is on the last page there, or the back page. All right, 18 says show your use of synthetic division. So there's 6 factors there, which means you have to do 6 synthetic divisions in all this space here. So use your space judiciously. I recommend you put 1 here, 1 here, 1 here, 1 here, 1 here, and 1 here. That's enough room for 6 synthetic divisions, and then circle the ones that are correct. It says circle each of the given binomials that is a factor of f of x equals 2x to the 4th minus 11x to the 3rd plus 14x squared plus 9x minus 18. And you're testing x plus 1, x plus 2, x plus 3, x minus 1, x minus 2, and x minus 3.
Please dial 31102.
And so here's what you're going to do. You'll put a synthetic division. Here's what I would do if I were you, is I would draw all your synthetic division boxes first to make sure that you have enough room. All right, I'm going to draw another one over here because my board is set up differently and I only have so much camera space. All right, there we go. But I'm going to fit them all in, right? So I'm going to try -1 and +1. Remember, I want the zeros of this. The 0 of this is -1. I want the roots. The root of this is 1. The root of this one is -2. The root of this one is +2. The root of this one is -3. And the root of this one is +3. And all of them are going to get the same numbers. 2, -11, 14, 9, and -18. So 2, -11, 14, 9, -18. 2, -11, 14, 9, -18. 2, -11, 14, 9, -18. 2, -11, 14, 9, -18. Over here. 2, -11, 14, 9, -18. 2, -11, 14, 9, -18. Now remember, the factor theorem says that a binomial is only a factor, or a polynomial is only a factor if the denominator from division, if the remainder from division, if it has a remainder of 0. So we're going to do all 6 of these and see if see which ones have a remainder of 0. So I put a 0 here. 2 plus 0 is 2, times -1 is -2. Minus 11 is -13, times -1 is +13, plus 14 is 27, times -1 is -27, plus 9 is negative 18, and negative 18 times negative 1 is positive 18, minus 18 is a remainder of 0. That means x plus 1 is a factor, so I'm going to circle. Here, for 1, I'm going to put a 0 here. 2 plus 0 is 2, times 1 is 2, minus 11 is negative 9, times 1 is negative 9, plus 14 is 5, times 1 is 5, plus 9 is 14, 14 times 1 is 14, minus 18 is negative 4. This does not have a remainder of 0, so x minus 1 is not a factor. I'm not going to do anything. I'm just going to leave it. I'm not going to circle it. I'm not going to X it out. I'm just going to leave it alone. So now I'm going to try negative 2. Put a 0 here. 2 plus 0 is 2. Times negative 2 is negative 4. Minus 11 is negative 15. Times negative 2 is 30. 30 times 14 is 44. 44 times negative 2 is negative 88. Plus 9 is negative 79. Times negative 2 is 158. 158 minus 18 is 140. So x plus 2 is not a factor because the remainder is not 0. So down here, we'll put a 0 here. 2 plus 0 is 2. 2 times 2 is 4. 4 minus 11 is negative 7. Times 2 is negative 14. Plus 14 is 0. 0 times 2 is 0. 9 plus 0 is 9. 9 times 2 is 18. Minus 18 is 0. Remainder of 0, that means that the factor that goes with a root of 2, that's x minus 2, that's a factor. Last 2 here, put a 0 here. 2 plus 0 is 2. Times negative 3 is negative 6. Minus 11 is negative 17. Times 3 is positive 51. Plus 14 is 65. Times negative 3 is 80, 190, negative 195. Negative 195 plus 9 is negative 186. Times negative 3 is, let's see here, positive. It's a really big number. It's like 300 plus 240, 540, 558. 558 minus 18 is 540. That's not 0. That means x plus 3 is not a factor. Last one here, put a 0. 2 plus 0 is 2. Times 3 is 6. Minus 11 is negative 5. Times 3 is negative 15. Plus 14 is negative 1. Negative 1 times 3 is negative 3. 9 minus 3 is 6. 6 times 3 is 18. Minus 18 is 0. And so that means x minus 3 is a factor. And that's question number 18. Okay. All right, question number 19. Almost done here, folks. It's not so bad. Question 19 says solve, and we got a polynomial equation: x cubed minus x squared minus 12x plus 16 is equal to 3x squared minus 5x plus 6. We want to set the whole thing equal to 0, so we're going to subtract 3x squared from both sides, 3x squared. We're going to add 5x, then we're going to subtract 6. These are all going to cancel, and the whole thing is going to become 0. Now, bring down the x to the third. Negative x squared minus 3x squared is minus 4x squared. Negative 12x plus 5x is negative 7x. 16 minus 6 is 10. So here is our polynomial right here. So we're going to use the rational root theorem to try and identify what we should be testing. Q is 1. That makes it easy. So Q is 1. The only factor of 1 is 1. P is 10. So what are the factors of 10? 1, 2, 5, and 10. So really all we have to try is plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So we're going to do synthetic division with these 8 numbers to find out if any of them work. We've got a 1, a negative 4, a negative 7, and a 10. So we're going to put in the half box, we'll put a positive 1. 0, 1 plus 0 is 1, times 1 is 1, minus 4 is negative 3, negative 3 times 1 is negative 3, plus negative 7 is negative 10, times 1 is negative 10, remainder of 0, we're good. That's one of our solutions. X equals 1. Okay, we only have 2 more to find because it's a third power polynomial. Now we'll try negative 1. So let's try negative 1. We got a 1, a negative 4, a negative 7, and 10. Now what you could do is you could factor this. You could turn this into x squared minus 3x minus 10. Factor it. set the factors equal to 0, and get your other two x's. Or you can just keep doing synthetic division. So put a 0 here. We've got 1 times -1 is -1. Minus 4 is -5 times -1 is 5. -7 plus 5 is -2. -2 times -1 is 2. Remainder of 12. So -1 is not one of the zeros. So now I'm going to try, let's try 2. 2, bring 0, 1 plus 0 is 1, times 2 is 2, minus 4 is -2, times 2 is -4, minus 7 is -11, 2 times -11 is -22, not a remainder of 0. Let's move on to -2. Put a 0, 1 plus 0 is 1, times -2 is -2, minus 4 is -6. -6 times -2 is +12, minus 7 is 5. 5 times -2 is -10, with a remainder of 0. And so, one of my solutions is -2. I can only have one more possible solution. Oh, by the way, oh man, I should have done this. I'm sorry. You know how I should have done all this on 1, -3, and -10. Okay, so 1, -3, and -10, in that case would have given me 0. 1 plus 0 is 1, times -2 is -2, -2 plus -3 is -5, -5 times -2 is +10, -10 plus 10 is 0. And what that now gives me here is x minus 5, and if I set that equal to 0 and solve, I get x equals 5. Or you can just keep doing synthetic division. But because this is a third power polynomial, there are only there can be up to 3 answers, and here's the 3 answers: 1, -2, and 5. I'm going to do questions 20, 21, and 22 on another day, and then post them so that you can see those. But you have enough information now that you should be able to look over some and review, and then you can review 20, 21, and 22 maybe on Monday. Okay? All right. Come see me if you have any questions. I'm probably going to have another review packet for you on Monday or Tuesday so that you can practice even more. All right? Good luck.